So, in terms of examples for variation and direct and inverse variation, okay, so for direct, we're given these ordered pairs, -12, -8, -6, -4, 0, 0, 3, and 2. We are asked, find the constant of variation. We can find the constant by using the equation of constant from direct variation, k equals y divided by x, which came from your notes, right there, okay? And plug in any of these points. You can plug in either 2 divided by 3, -4 divided by 6, or -8 divided by y. The choice is yours. Okay? I'm going to do -8 over -12. And I get 2 divided by 3. So k is 2 divided by 3. We then write the equation, y equals 2/3 x. Easy. Okay, the next one is a little different. Instead, it says the variable y varies directly as x and y equals -16 when x equals 2. It wants us to find the constant variation. We know that that's going to be k equals y divided by x, which is going to equal -16 divided by 2, which gives me -8. Then write the equation, y equals -8 times x. And then we plug in these three values into here. So for y equaling -8 times -1, I get 8. For y equaling -8 times 1, I get -8. And for y equaling -8 times 2, I get -16. Okay? And those are the first two. Next two, for number 3, is asking if the following ordered pair represents direct variation, find the missing value. If it says direct variation, that means they're going to have the same k. So represents, ordered pair represents direct variation, meaning have the same constant k. Okay? Which means we can set these both equal to ratioed fractions, i.e., we can do 7 over 2.8 equals -4 over x. And we can cross multiply, which is going to give me 7x equals -11.2. Divide by 7. I get x equals -1.6. All right? 2.8. It's 2.8. Sorry. Okay? Now, the other thing we need to talk about here is that identifying which of the following graphs represent direct variation. Now, here's the thing. Just because a graph goes through 0, 0, which is a major requirement, doesn't mean it possibly can be an actual answer. D, obviously, is our choice and is through and through a good answer. Positive slope, goes through 0. But B also is technically an answer, too. The reason why we don't really like B is because it has a negative slope. In the theoretical world, great. In the real world, not great. Okay? So yes, B is a direct variation graph, but only in theoretical. If you apply real world constant, you cannot have negative k's, guys. And that has a negative slope. All right, now let's take a look at inverse variation. Inverse variation, like its counterpart, stark contrast, okay, is basically we have the same kind of set of problems here. We've got -5, 2.4, -3, 4, -2, 6, -1, 12. We want to find the direct variation of this, so we need to find the constant. Direct variation constant is k equals xy, okay? So we do k equals xy, and from there we get k equals -1 times 12, which gives me -12 as my answer. So my equation will be y equals -12 over x. Okay. Now, from there, we can do number 6 next, which is the variable varies inversely as x, and y equals 12, and x equals 7. So we can use k equals x times y, which is going to give me k equals 12 times 7, which gives me 84. So my answer for writing the equation representing this relationship will be y equals 84 over x. We plug in our known values. Y equals 84 over 5 equals 16.8. Y equals 84 divided by 10 equals 8.4. And y equals 84 over 16 equals 5.25. Okay? Again, just simply using the variation to find x values. And obviously the coordinate points would have been 16.5, 16.8 and 5, 8.4 and 10, 5.25 and 16. Wait, I'm actually backwards on that. Flip them. So it would have been 5 and 16.8. Sorry, I said y first. Okay. And find next one we have, which is if the following ordered pair represents direct variation, find the missing value of 4 and 0.2 and x and 8. Again, since both of these are equal to the same constant, we can basically take k equal xy and set it equal to xy because they're both sets of the same constant. Okay. And we get 0.8 equals 8. X divided by 8. And we get x equals 10. Oh, sorry, 0.10. I should rewrite that so it's a little clearer. Hold on. 0.01. There we go. So 0.10. If you want to put 0.10, that's fine, or 0.1, that's fine. Okay? And finally, for this set of problems, we've got sketching the graph of a constant variations is 4. So let's go ahead and make a table real quick. A little impromptu T-chart. Okay. We have x and y, x and y. So let's see, we got -2, -1, 8, 1, and 2. Meaning that if we go to a graphing calculator right here, okay, we type in, remember its carrot variation is 4, which means y equals 4 over x. Let's do 4 divided by, whoops, wrong one, divided by x. And we do second table. There's our error. So let's see, -2 is -2, -1 is -4, 8, we'll come back to you. 1 is 4, 2 is 2, okay? And 8 is 0.5. So let's go ahead and go over here. So we go over to 8, go up a half, which means it's going to be also the same right there, okay? We go over 1, up 4, over 4, up 1, over 2, up 2. So you can probably start to see a pattern here developing with these guys when we graph them. Okay? All right. The other one, we're going to go back 8 down a half, back 8 down a half. Okay, over 4 down 1, down 4 over 1, down 2 over 2. There we go. Okay? And there we go. Right? Again, the graphing calculator will definitely help you through these. If we graph it, there's our shape. Okay? The larger the numerator in these fractions, you'll notice the larger and larger the curve gets away from the intercept, meaning that there's more variation in terms of, and variation is a bad word because we're using it. There's more individuality, I guess is another way I could put it, in their in the arc's distance to the asymptotes. Those asymptotes again being where's my pen? Those asymptotes being the x and y intercepts. Okay, there we go.